Hi, I'm Mohit Setia. I'm an engineer on camera software team. Welcome to implement high-resolution photo capture. Advancements in camera hardware and computational photography make high-resolution captures possible. But taking full advantage of that quality means managing trade-offs, particularly between processing time and final image quality. I'll go over high-quality photo processing and how to manage those trade-offs for your app. First, I'll cover different types of high-resolution photos. Then, how to configure and capture them. And finally, I'll discuss how to keep your app responsive throughout the process. First up, high-resolution photos. The preview stream gives you a screen resolution image, suitable for showing the camera's view. But in photography use cases, higher level of detail and low noise is expected. Also, high-resolution image is required for photo cropping, zooming in on details, or image analysis. High-resolution captures address this. Let me define what they are. A high-resolution photo, typically 12 megapixels, captures the scene at a higher resolution than the previous stream. 24 megapixels and 48 megapixels take it a step further. The camera captures it at an even larger resolution. That means significantly more detail and clarity. Starting with iPhone 14 Pro and iPhone 14 Pro Max, the camera system features a 48 megapixel quad sensor. A quad pixel sensor design allows capturing photos at full resolution with highest level of details, or group pixels in 2x2 clusters of the same color to capture more light. This is a 48 megapixel photo captured on an iPhone. It shows sweeping coastal landscape, cliffs, beach, and oceans stretching to the horizon. It is 4 times the resolution of a standard photo. And it is captured using a single frame from the sensor. Notice the fine rocks on the 100% crop of the coast, clearly visible in incredible detail, and the intricate patterns on the side of the mountain. This is the power of 48 megapixels. More detail, more clarity, more to explore. Starting with iPhone 15, the camera supports 24 megapixel photos. A 24 megapixel photo capture consists of multiple steps. First, the camera uses combined pixels on the quad sensor to generate a 12 megapixel multi-frame fused high dynamic range image. Then, the computational image processing pipeline, called photonic engine, combines that with high-resolution 48 megapixel image captured at full sensor resolution for rich details, resulting in a 24 megapixel image with incredible quality, double the resolution of a 12 megapixel image, with only about 50% increase in the file size. It balances light and detail while keeping the file size manageable for storing and sharing. Starting with iPhone 15, the camera app defaults to this capture mode. 24 megapixel and 48 megapixel capture support has been extended to the telephoto camera on iPhone 16 Pro and the ultra-wide camera on iPhone 17. So, these are the types of high-resolution photos available across iPhone cameras. Now that I've defined the high-resolution photos available on iPhone, here are the types of high-resolution captures that you can request in your app. First, the most common use case, the fully processed photo. This is a multi-frame fused image. It goes through photonic engine that extends dynamic range and improves fine details. Second, exposure brackets. Multiple exposure frames of the same scene. This is useful for creating a high dynamic range photo capture and scenarios where selection of multiple exposures is required. Third, bare raw photos. RAW gives you minimally processed data straight from the sensor. This is ideal for post-processing and editing use cases. And fourth, Apple's ProRAW. ProRAW combines the flexibility of RAW with iPhone's image processing. It gives you more flexibility when editing exposure, color, and detail. To learn more about RAW format, watch Capture and Process ProRAW images from WWDC 2021. Next, let me share how to configure the capture session for high-resolution photos. I'll start by creating an AV capture session, and then configure the session. Note, only the photo preset supports 24 and 48 megapixel photos. Other presets do not support it. Next, I'll pick the right prioritization for my app. A speed capture delivers fastest, with the least processing. A balanced capture gives medium delivery speed and good quality. A quality capture takes the longest, but delivers the best quality. This is covered in more detail in Capture High-Quality Photos Using Video Formats from WWDC 2021. So, while configuring the AV capture photo output, I'll set Max Photo Quality Prioritization to Quality for demonstration of a high-res capture. This tells the session to prepare resources for all three prioritization levels: speed, balanced, and quality. The availability of some high resolution depends on this setting, and I'll cover that little later in this video. Next, I'll select the largest dimensions that I would request in this session. Starting from iOS 16, you can check the supported max photo dimensions on the active format of the device. Supported max photo dimensions lists all possible photo dimensions on the current format. Here, I'm selecting the largest available dimensions for demonstration. But you should pick the dimensions that fits your use case. Complete photo output configuration before committing the session configuration. Changing these settings after commit triggers a lengthy pipeline reconfiguration. When ready to capture, set max photo dimensions and photo quality prioritization on AV capture photo settings for the current capture. And then set up the delegate to capture the photo. Setting max photo dimensions is a request, not a guarantee. The system looks at the light level, scene, and available processing and picks the best path it can. The actual dimensions come back to your delegate inside AV capture resolved settings, which also notifies the delegate when the capture is complete. You can customize quality prioritization and max photo dimensions on each capture. That means you can support multiple quality levels and dimensions in the same session. No lengthy reconfiguration between captures. High-resolution captures require specific resource allocations based on photo quality prioritization and max photo dimensions. If the system has not pre-allocated these resources, the allocation happens at the capture time, which can slow things down. To avoid this slowdown, use the method setPreparedPhotoSettingsArray on AV capture photo output to signal how you plan to capture future photos. For example, if the app features a 48 megapixel mode, call setPreparedPhotoSettingsArray as soon as that mode is activated. So the resources are ready before the capture happens. Here's how you can implement this. As early as possible, create a Prepare Settings object. Set the appropriate max photo dimensions and photo quality prioritization. Then call setPreparedPhotoSettingsArray. Later, when ready to capture, create a new Capture Settings object that matches the Prepare Settings configuration. Keep in mind, you cannot reuse Prepare Settings object for the actual capture. Create a new Settings object, but make sure its configuration matches, so the capture aligns with the pre-allocated resources. Capturing high-resolution photos requires processing of a large number of pixels. This processing can take several seconds. I'll now provide some best practices to ensure that the app remains fast and responsive during this process. When a photo is requested, It first goes through a capture stage, then moves to a processing stage. AV Capture Photo Capture Delegate receives notifications throughout this process. For example, did capture photo for resolve settings and did finish capture for resolve settings keep the app up to date as processing continues. Processing can take a different amount of time based on selected photo quality prioritization. A photo with quality prioritization is delivered with the best image by utilizing longer processing time. A photo with balanced prioritization delivers optimal quality with appropriate processing time for common cases. A photo with speed prioritization is the fastest way to get the photo captured, but without the improved quality that comes with longer processing. You can capture 12 megapixels across all three prioritization levels. 48 megapixel images, because they are only a single frame as covered earlier, are available with either balanced or quality prioritization. 18 megapixel and 24 megapixel are multi-frame fused images and take longer to process, that only quality prioritization allows. The 18 megapixel in this table is only available on the center stage front camera on iPhone 17. To learn more about the center stage front camera, check out the Support Center Stage Front Camera in your iOS app from WWDC 2026. AV Capture Resolve Settings has a photo processing time range property. It tells you how long to expect before the photo is delivered to your delegate. The next photo can only be captured once the previous photo finishes processing. This delay between the two captures is referred to as shot-to-shot delay. Enabling responsive capture on AV Capture photo output allows overlapping captures. A new capture can begin once the capture stage of the previous photo finishes. No need to wait for processing. Observe the capture readiness property on AV Capture photo output to know when the next photo can be captured. This reduces the shot-to-shot delay for the second photo. It helps you avoid missing the moment. But keep in mind, each photo still takes the same processing time as before. To reduce shot-to-shot delay even further on high-quality captures, adopt deferred photo processing. When you enable deferred processing, the system delivers a lightly processed proxy photo immediately after capture. You receive it via the did finish capturing deferred photo proxy delegate callback. Final photo processing happens in one of the two ways: on demand, when you request the final photo through the photo library, or in the background when the system decides the conditions are favorable, such as the device being idle. Watch Create a More Responsive Camera Experience from WWDC 2023 for deep dive into deferred photo processing. Enabling deferred photo processing significantly improves responsiveness by reducing the processing time blocking the next capture. This further reduces the shot-to-shot delay for all subsequent photos. You can now capture more high-quality photos in less time. With this approach, time spent on the processing stage shrinks significantly, while the capture stage remains the same. Deferred processing lets the system take longer to finish processing a photo without blocking the next capture. And because that work happens in the background, it doesn't share memory with the capture session. That's what makes multi-frame fusion captures possible, like 18 and 24 megapixel. To prioritize responsiveness even further, turn on the Fast Capture Prioritization property on AV Capture photo output. When you turn on Fast Capture Prioritization on photo output, the system detects when someone takes multiple captures in quick succession. It then adapts the photo quality from the highest quality setting to a balanced quality setting. So, in the photo capture timeline, as someone requests rapid captures, the system dynamically adjusts photo quality prioritization to balanced. Balanced captures require less time for both capture and processing. The result is a speed boost when the rapid captures are happening. Starting with iOS 27 on iPhone 16 and iPhone 17, the system also processes balanced fast captures later using deferred processing. This further minimizes processing time, giving a faster capture experience for much longer. To illustrate this, I'm out covering a very intense ball game between camera team members. On screen, a basketball court where the action unfolds. At first, I start without deferred processing, responsive shutter, or fast capture prioritization. Notice the capture button as I try to take photos of the basketball shot. It keeps spinning while processing the photo, preventing me from taking another shot. I end up with a single photo of the shot. But I can do better to capture the moment I want using the APIs to manage responsiveness. I enable deferred processing, responsive shutter, and fast capture for the next shot. This time, the capture button stays responsive while I capture the best moment. As I press the capture button, AV Capture Session starts capturing quality photos. But as I continue, it detects fast captures and intelligently transitions into balanced captures. The difference is noticeable. One blocked capture versus 5 responsive shots of the same moment. This made for much more responsive capture experience. In this video, I shared best practices for building a responsive photo capture app that captures photos with highest quality and resolution. If you are building a photo capture app, identify the resolution you want. Higher resolution, like 24 and 48 megapixels, give people more details to crop, zoom, and explore. But they need more memory and processing time. Pick the quality prioritization that fits your needs. Speed, balance, and quality each trade off delivery time against image fidelity. Match the level to what your app demands. And if you need the highest quality captures, turn on deferred processing and responsive captures. Without them, each photo blocks the next. And people using your app might miss the moment they can't get back. To further optimize your camera app, watch Build a Responsive Camera App that launches quickly from WWDC 2026. Build a camera experience that's fast when it needs to be, and uncompromising on quality when it matters. Thanks for watching.